We're studying IGCSE physics, and we're starting thermal effects revision. Now we'll try to cover the whole chapter in this class if possible, and we'll look at some past year questions. So revision 1. Anas, can you hear me? Anas? Now let's start with the chapter. Okay, thermal effects. Ayan, can you see the book?
Yes, sir.
All right. Perfect. So the thing is, we look at it, page number 100. Thermal effects. Now this chapter is mostly based on a few key things. We look at that. So we look at the syllabus first. The syllabus for this chapter is states of matter, kinetic theory. We have expansion. We have flow of heat, which is conduction, convection, radiation. Finally, we have thermal capacity, and we have specific heat capacity. Finally, we have latent heat. That's most of it right here. We'll also add in kinetic theory, we have Brownian motion. Now, Ayan, quick, tell me, which of these do you find the most difficult?
Thermal capacity and specific heat capacity.
Thermal capacity, specific heat capacity. All right. So should I start from the beginning, or should we directly go over there first?
Sir, we can start from the beginning.
Beginning, all right. Let's start. First things first. States of matter. Now, in states of matter, there are a few key things we're looking at. We're looking at what are the arrangement of these, what are the properties, how are particles arranged, especially all of those things. Let's see. The three states of matter: solid, then we have liquid and gas. We don't study plasma, Einstein's bose, condensate, all of that in IGCSE, obviously, not even in A levels. They, general knowledge, there are about 8 states of matter. But we only look at 3: solid, liquid, gas. Now, first thing is solid. We look at a few key things here: arrangement. We look at motion. That's about it. Let's start. First thing first is solid. The arrangement of solid is a regular arrangement or solid. Regular arrangement. Start writing. Arrangement. Which is the same thing as lattice, or lattice of what was the word of atoms. Done. Next thing is we look at all right, back to class. Now, the first thing first What else do we have on this? We have arrangement, motion, and we also look at, let's say, attraction. So what's happening here is we have regular arrangement done. Attraction, we have strong intermolecular forces of attraction. IMF stands for intermolecular forces. And lastly, we have motion. What does that mean? Motion means atoms vibrate to and fro, can't change position. Write all of this in your notebook. Now, one thing we'll add in arrangement as well, that we have fixed volume and shape. Let's put that in attraction. Next, liquid. Now, Ayan, can you tell me what is the arrangement of a liquid?
So the particles side of each other and the force of attraction is weaker than that of solids.
All right. So the arrangement is, let's say, random. But attraction is weaker IMF, intermolecular forces, than solids. What does that mean? Well, it has fixed volume, but changes shape. So that is what the weaker IMF does. It allows the liquid to change shape. And that also affects the motion. How does it affect the motion? Atoms slide over each other. That's it. Random and arrangement, we can also say. Arrangement takes shape of container. Done. Now gases are also random. Anas, can you hear me? These guys have negligible intermolecular forces. Now they're so less that it's almost not there. Now there are a few things as well. Can these guys be compressed or not? Well, gases can be compressed. Liquid cannot be compressed. They will ask you this in the MCQs. Cannot be compressed. Solids obviously cannot be compressed. Now the thing is, if you have a fixed shape or a fixed volume, then you cannot be compressed. If you don't have a fixed volume, then these substances can be compressed. Lastly, atoms collide with each other. Each other. We'll add a few more things here. In solids, we'll say the arrangement is close together. In liquid, the arrangement is also close together. Let's say more distance than solids. And finally, gases are far apart. Is there anything else? No, that's it. Atoms collide with each other and, well, that's it. Now, there's nothing else they can ask you from states of matter. They can ask you about the reasons of all of these, but I think you can do that. right? They'll ask you why can liquid not be compressed? We'll say because liquid has a fixed volume and they can only slide over each other, so they cannot be compressed, especially the fixed volume part. Ayan, Anas, any doubts? Should I move on?
Yes, sir.
Kinetic theory. Now, what does the kinetic theory tell us? Kinetic theory tells us the more kinetic energy something has, the higher the kinetic energy, the faster the particles move. This results in a higher temperature. So we can easily establish an equation from this. What we can establish is that Ke is directly proportional to speed because we know K is half mv squared. And lastly, we have, okay, K is directly proportional to velocity. And velocity is directly proportional to the temperature. So if you increase kinetic energy, the temperature increases. But how can I use this theory to derive more conclusions from this? The first thing is how is pressure exerted? How does gas exert pressure? Write this, it's very important. Actually, all of it. Now, this is the first question from this. And we can use the kinetic theory to answer this. Well, first thing is, we'll say gases or gas particles collide with container. And change direction. Before we do that, let's say, let's just say, this exerts a force on walls due to change in momentum. Or let's say, change in momentum occurs and a force is exerted. Now, the word change in momentum is the key part here. Change in momentum, collide, and a force is exerted on walls. That's important. Also, change direction. Well, everything is important, yeah? But especially change in momentum. The last thing is several collisions. Can be averaged. When averaged, cause pressure. Are any questions?
No, sir.
I want you to add one thing. A force is exerted on the surface area of the walls. Then the next thing you just have to do is give an equation here, which is P is equal to force over area. Pressure is force over area. Unit is Pascal. Well, they won't ask you the unit, but you should know. Pressure is force over area. Now, key things again: change direction, collide, change in momentum, force is exerted on area of walls. Several collisions take place, and this is important. Write this in your notebook. Tell me when you're done. We can also answer another question on this. Okay. How does temperature affect pressure? Well, we know what causes pressure now, but how does temperature affect pressure? Well, what we realize is higher temperature increases kinetic energy of particles, so they move quicker. Let's say so they move faster and collide more frequently. This causes decrease in pressure. Any questions?
No, sir.
No.
Finished. That's it. I can write this in your notebook. Tell me when you're done. Last thing is, well, it's vice versa, by the way. If you decrease the temperature, the opposite happens. Lower temperature decreases kinetic energy of particles, so they move slower and collide less frequently. Therefore, the force exerted, less force is exerted on the walls. Same thing for lower temperature. Now that's fine. What else can we derive from this? We can derive something called what is Brownian motion. This is key. This will be asked in MCQ, which is guaranteed to come. What is Brownian motion? Always. Now, you need to know a few things. Gas particles move randomly, constantly moving. Let's just say particles are constantly moving. Particles move randomly. What else do we know from this? Let's say move in straight lines. Due to collision with other particles. Now this part, due to a collision with other particles, is something you need to understand. But these three points is something which you must be clear about this. All right? Particles move randomly, particles are constantly moving, and particles move in straight lines. Any questions?
No, sir.
All right. Yep, that's it. Next. Now, how do I, you'll be asked to present an experiment for Brownian motion. It's experiment proving Brownian motion. This is important as well. And tell me, what is the experiment?
So you place small particles inside a fluid, such as liquid or gas, and the small particle can be dust or just crumbles.
Okay, dust, fine. What happens then?
They'll be seen as constantly changing direction, and movement will constantly be changing. This is because they're being constantly bombarded with particles of the fluid.
Perfect. Now the next thing we have to look at is, or guys, can you hear me properly? Now there's a lot of partying happening outside. If you can't hear me properly, then tell me. I'll change my position. Now let's continue. The next thing is, we'll make a microscope. How do we make a microscope in the exam? You'll have to make one. All you have to do is make a base, make a stand, then attach something like this, and that is the microscope. Easy one, at least. All you have to do is put a smoke cell below it and cover it with a lid. A glass lid, obviously, because you have to see inside it. And this is a smoke cell. What happens is, inside it, if you, let's say I'm going to put some smoke particles inside it. And I can't see air, obviously, but I can see the smoke particles. And what happens is, when you shine light on it like this, you'll realize that the smoke particles are moving, and they're moving constantly, and they're moving in straight lines. What that means is, therefore, I realize that proves it. Now I'll just write the conclusion from this experiment. We did the apparatus already. You need a smoke cell, a microscope, and a light source. The conclusion is, smoke particles are constantly moving. randomly, cannot say, or let's say we cannot say, what is causing motion. Hence, what we realize from this is, since we cannot see what is causing motion, okay, hence air particles must be colliding with smoke particles causing motion. Right? Any doubts? Any questions?
No doubts.
No, sir.
Now, these are 3 points. This will be 3 marks in the exam. And especially this part is key, that you cannot see what is causing the motion. Therefore, air particles must be colliding or gas particles. Just to write the apparatus, you write it right here. You need a smoke cell. You need a lid. You need a microscope and a light source. This will come in alternative to practical. We'll also start that perhaps in the next class. We'll see. We'll finish space physics on ATP after that. In chemistry, we'll be starting ATP from the next class. Now, okay, that's done. Fine. What is the next thing? The next thing is, let's see. Let's finish boiling and evaporation. Boiling versus evaporation. Write all of this in your notebook. Quick. The first thing first is the differences. Let's start with the similarity. Or let's start with the definition. What is boiling? Boiling is change of state from liquid to gas at constant temperature. All right. But what is evaporation then? Evaporation is a bit different. Evaporation is escape of highly energetic particles from the surface of the liquid. Happens at any temperature. Anas, read this out loud. The definitions.
All right.
Quick.
Evaporation, escape of highly energetic particles from surface of the liquid, happens at any temperature. Boiling,
Happens
change of
at any temperature.
from liquid to gas at constant temperature.
All right. Change of state from liquid to gas at constant temperature. But that's not enough. That's the definition. If they ask you about, if you give that, you'll get 2 marks for this. You'll get 1 mark for that. Usually, that's the definition they ask you. Not a lot of marks for that. But we'll have to look at differences, and there are lots of differences here. First thing is boiling is endothermic. Well, actually, both of them are endothermic. Let's remove that part. Let's say, okay, happens throughout liquid, while evaporation happens where? Ayan, tell me. Happens at surface. Next point is this happens at constant at fixed temperature. On the other hand, this happens at which temperature, Anas? Tell me. At any temperature.
Any, oh,
All right. Now, third point is temp is constant. Temperature is constant. Don't write temp, write the full thing. Constant. But on the other hand, in evaporation, temperature decreases. Causes cooling effect. We'll have to understand why that happens as well in a second. And is there anything else here? Temperature is fixed. Temperature is happens throughout liquid. Yes, Anas?
Are we doing topic 2 right now?
We are doing topic 2. Yes, we're doing thermal effects, topic 2. Now, anything else here? No, that's it. You should know that. That's good. Now, why does evaporation cause cooling effect? Write this. It's a 5-mark question in the exam, by the way. That's one question. Ayan, can you answer this? Why does evaporation cause cooling effect? And the other question is, why is temp constant in boiling? Ayan,
Yes, sir.
first question, can you answer it? Or should I help?
I can try. It's because the most heated particles are the ones that leave the liquid in the form of bubbles and they turn into a gas and leave. This
Perfect.
decreases the average temperature of the entire liquid.
Exactly. So more
Because the
energetic
cooler-
particles leave and less energetic remain. That's 1 mark. Next thing is decreases average temperature. Fine. Let's change the question a bit. Now we know why evaporation causes cooling effect. Let's say, why does evaporation cause cooling effect? Or let's say evaporation of sweat cause cooling effect on body. That's one question. So what we'll write is, write this in your notebook quick. Anas, read this. Why is temperature constant in
Why is temperature constant in boiling? Energy is, it says energy is constant, not temperature. So we need the answer for temperature. Right?
Yes, temperature is constant, right? So read it quick.
Energy is used in separating particles by doing work against intermolecular forces of attraction.
Continue.
Energy is used up in breaking bonds. Kinetic energy or speed of particles does not increase, so temperature is constant.
Write this in your notebook quick. 3-mark question.
Okay.
And that should be it about boiling and evaporation. Why does evaporation cause cooling effect? Because one thing we know is particles decreases average temperature, but that's just 1 mark, 1 out of 2. You have another mark here, which you have to say is heat flows from the body to the liquid, because we know that temperature goes from cool to hot. Sorry, hot to cool, always. So if something is hotter than and it's in contact with liquid, the temperature or the energy will flow from heat will flow from the hot body to the cool liquid. Therefore, heat is lost. Ayan, any questions?
No, sir.
Are you writing?
Yes, sir.
Now, one last thing is factors affecting evaporation. There are a lot of things here which they ask you in the MCQ and in theory, lots of times. And even in perhaps in every ATP experiment, you have to mention this about evaporation. If you're dealing with liquid, this thing has to be there about evaporation, the precautions. First thing is wind. Next thing is temperature. Next thing is surface area. Next thing is humidity. And anything else? No. Wind. What does wind do? How does wind cause increase in evaporation? Wind removes temperatures. Particles have more energy. More kinetic energy to escape. Let's just say more particles with high kinetic energy. Surface area, more particles in contact. More particles at surface or close to surface. They ask you the reasons in the exam. That's guaranteed. Humidity is already many particles in air. Let's say in atmosphere. Wind is directly proportional to evaporation. Temperature is directly proportional to evaporation. Surface area is directly proportional to evaporation, and humidity is inversely proportional to evaporation. Now, Ayan, do you know what inversely proportional means and what directly proportional means? Anas,
Sir, could you repeat that?
my question is, do you know what inversely proportional means and what directly proportional means?
Yeah, if direct proportional means if one thing increases or decreases, the other thing also increases or decreases.
Exactly. So if you increase wind, evaporation increases. Increase temperature, evaporation increases. If you increase humidity, evaporation decreases. Opposite happens because it's inversely proportional. And I think that's a good way of putting it, because in the exam they'll usually ask you what happens if I increase the surface area, or why did evaporation increase? Yes.
This inverse, how do you write inversely proportional?
Yes. Let's say I have A is inversely proportional to B, 1 over B.
Okay.
And if I have to say directly proportional, that's B. Now, on us in the exam, we don't write directly proportional. We just say increasing the wind will increase the evaporation. All right. This is just a way of memorizing it. Even if you write it, there will not be actually a problem. So don't worry. Finish writing. Anas, where are you right now? I want you to make a graph as well, especially on the evaporation part. This is particles. These are particles before evaporation. Let's say these are the particles before evaporation. And these are the particles after evaporation. This scale right here is energy, and this scale is number of particles. All right, guys, any doubts? Anything quick?
No, sir.
Right, all right, all right. We have done all of this. I think the only thing left are thermal properties, expansion, contraction, and all of that. Then we'll have latent heat and specific heat. Anas, how much have you written?
I'm on the question. I'm on the third part of the question, like kinetic energy, speed of particle.
Correct. So we finished evaporation. We finished cooling, cooling of object. We have done. Let's see, just a second. I'll show you the syllabus. Correct. Okay, by the way, Ayan, you know what how a thermometer works? What is basically, let's say, the sensitivity of a thermometer, the range of a thermometer? Do you know all of that?
Yes, sir.
Do you know what? Okay, that's fine. So have you studied about in school? Have you studied about thermometers, about thermocouple thermometer, liquid and glass thermometer? Have you done that?
No.
No, because okay, all right, then that's good. Because they're not in syllabus anymore. Even sensitivity, range, all of that is not in syllabus. Well, you should know what a basic thermometer is.
Wait, what is not in syllabus anymore?
Thermocouple thermometer and thermocouple thermometer. This one.
I don't even know what that means. So that's
This
okay.
one. Okay. It's not in syllabus. This changed, I think, in 2019. Or perhaps 2022. Actually, 2022. Yeah, last year's batch. They had it, I think. You don't have it anymore. Now we're going to look at a few more things, especially on what were we doing? We did everything on evaporation, on all of that. We will look at Uh, let's look at expansion real quick.
You're on mute. No, you're on mute.
Yeah, guys, can you hear me? Whatever you have on the board, keep writing. Okay. If you have any questions, ask.
Okay.
Ayan, any questions? Quick, ask me.
He's not in the meeting.
He's not in the meeting. All right. Okay. Okay. Anas, any questions?
No.
No, fine. Now we look at. I want you to read this out loud, quick.
All right. What causes expansion? Heating a substance causes kinetic energy of particles to increase, and particles vibrate faster. As a result, they move further apart and volume increases. Degree of expansion: solid is less than liquid, and liquid is less than gas.
So solid is yes. So that means gas is the most, and liquid is in the middle, and solid is the least. Is that clear? So gas expands more, and solid expands even least actually. The applications are two things. You have biometric strip You have overhead cable, and you have bridges. All of these expand. Now what happens is, look, when you have, let's say, have you seen these overhead cables on the street, perhaps? You have these wires going like this.
Yeah.
Okay. But what happens is, what will happen if these wires become, let's say, very loose? If they become very loose, they'll come like this. Yes. Is that what will happen? Anas?
Yeah.
If the wires become loose, that is what will happen. Fine. Now, what happens if, let's say, the wires become too short or too tight? Then what happens is the wire will break. The wire will break apart like this from here.
Yeah.
So now what is our job? Our job is to make sure that the substance does not break apart or does not, let's say, become too loose. We don't want both of these things to happen. How do we fix it? Well, one way is we have to actually we don't want it to become too let's say uh, too tight, so it breaks apart. So what we'll do is we'll keep it loose, and so when it does become shorter, it will not be too tight. Let's see what happens actually. First thing is, write this down. Heating expands, cooling contracts. So Anas, on a hot day, will the wires contract or expand?
Expand.
Expand. And on a cool day, what will happen? They will expand or contract?
Contract.
Contract. So overhead cables must be slack. So on cold days, or so when they contract, on cold days, they do not, let's say, snap or detach. Read it out loud, Anas, for overhead cable.
Overhead cable must be slack. So when they contract on cold days, they do not detach.
Detach. All right. One metal expands more than other, causing turning effect. Let's say causing bending. Uses in automatic heating systems. Now, have you done the bimetal strip? Do you know what it is?
No.
Anas, read the bridges part.
All right. Bridges. Gap left in bridge for expansion on hot days.
Okay, perfect. So expansion, you should leave some gaps for that. Just a second, I'll tell you if you have anything on bimetal strip. Never mind. Okay. Now, Anas, you should just memorize this. You don't have to understand it. It is key that you understand that this is what a bimetal strip looks like. You have two metals, okay? And what happens is the metal bends. Let's say you have two metals. One of them is black, the other one is green. Now, Anas, tell me if let's say one of these expands more than the other, what will happen? What if this happens?
So if the metal expands more than the other one,
Yeah,
then
so what will happen?
there will be more weight on the metal that has expanded more.
So look, it will look something like this. So if
Oh.
one expands more than the other, then it looks like this. But in reality, it doesn't really look like this. What happens is it will bend like this. something like this. Something like this. All right. This is what it looks like. Something like this. So what you will realize that one side is shorter and the other side is longer. Right? You understand? Look, if one of these sides expands more than the other, what happens is this will bend like this. So let's say this does not expand, or one side does not expand, but the other expands. So what will cause is whichever expands more will bend like this. And you'll get something like this. Now, Anas, can you tell me which of these is longer, the black one or the green one? Is the
They're
black
both
one longer?
equal.
Which one?
They both are
They're,
equal.
they're not equal though. Look, over here,
Um,
one of them is longer. Let's measure it. Now, if I measure this side, let's say this is from here to here, it is, let's say, 10 cm. But from here to here, it's actually much less. That's only 7 cm. So do you see that one side is less than the other?
Yep.
So that is basically how it bends, how metal can start bending because of expansion. Now you should either take a screenshot or write this down, and we look at the next thing, which is thermal capacity and latent heat. Taking a screenshot?
Yep.
Now you should write it, you have to memorize it. And as one thing I'll tell you is how you can solve 100 past papers, okay? But if you don't finish the revision of the chapters, then in the exam, A star is not going to be there.
All right.
What do you
Can
understand?
I see the overhead cables thing again?
Yes. Now these are important. These are very important. They will be in the MCQ. And even this guy.
All right, done.
Done. And especially these guys, right? Everything I give you is important. The book may be like a story, and it's hard to understand. But these notes you can understand. I think if you have any doubts, ask me. Thermal capacity. Let's start with thermal capacity, and let's see.
All right.
First thing first is an object increases what? Increases kinetic energy. And what does that increase? What does that cause?
Does this expand?
No, they do expand, but that's what we're talking about. Heating an object increases kinetic energy and particles move faster, right?
Yeah.
Hence, particles move faster and more collision takes place. Obviously, if they move faster, more collision is going to take place, right? If I have a box like this, and right now they're moving like this. One guy is, let's say, you have two particles. One is here, and I have another one, let's say right here. Now they're moving very slowly around the particle like this. One of them is going in that direction. So they're not really moving that fast. But if I increase the temperature a bit, they will start moving randomly like this. And you think this will cause more collision? Right, Anas? If they move faster, it causes more collision. Collision with the walls, collision with each other. That's what it means to heat something. But if you cool it, then the particles start moving like this, slowly. That's like 2 collisions per second. But if you heat it, hundreds of collisions per second. So that is what this means. So what we realize is energy of substance, or let's say of particles. Let's say energy of substance is directly proportional to kinetic energy of particles. Is that clear? So Anas, if I increase the kinetic energy, what will happen to the energy of the substance?
We can repeat.
If I increase the kinetic energy, what will happen to the energy of the substance? If I increase this, what will happen to this? Then?
I think it will also increase.
Yeah, because directly proportional, right?
Yeah.
Okay, correct. So let's continue. Now, the next thing we're looking at is, well, that all of this, you don't have to write that. Let's start from here. Specific heat capacity. You have to write this. Specific heat capacity. And the unit is joule per kg or joule per gram. Now we understand from the units itself that what this thing means. What this basically means is it is the amount of energy. Write this down.
What is J?
J is joules. J is joules, which is the unit of energy. Tell me when you're done.
All right.
Look, Anas, will tell me, keep writing and tell me, how are you revising for your exams?
Oh, for exams, I'm like just I have to start studying from chapter 1. I have started it because I still have homework to do. So after the homework, I'll start. I have to complete my homework today for your classes and school.
All right. All right. Homework. Now, one thing, Anas, is I want you to read chapters, which is important because look, you can do homework, you can know everything, but Anas, it's very important that you understand, let's say, what is joules, what are what is specific heat capacity, because this is all of this is in the notes. In Z notes is there, it's in the book it is there. You have to read at least one chapter every day. Is that clear? Like a storybook. You have to read it. Just don't understand it, don't solve questions, just read it
Right.
once. So which chapter will you read today? Or tell me. In which subject and which chapter? Ayan, can you hear me?
Yes, sir.
We're looking at specific heat and thermal capacity. Finish writing this quickly in your notebook.
All right, sir.
Wait, class is over.
Class is over, right? Just finish this and we're done. Now I'll just tell you what these things mean. C over here is specific heat capacity. T is change in temperature. Now, because Anas, I have to teach you all of these things before you can solve past papers or solve questions.
Yeah. So wait, does the triangle mean like change?
Triangle means delta, change, yes. That triangle over there means delta. We call it delta T, okay? And delta is the same thing as change. This is delta. And Q over here means heat. Q over here means thermal capacity. Now you can use E, or if you want, it's fine. But these two Q are actually a bit different. This is heat energy, or let's say heat energy supplied. The energy you're providing to it. M is again mass, and C is specific heat capacity. Finish this. What do we have after this, Ayan? Ayan,
Yes, sir.
what is the next class?
ICT.
ICT. All right. I'll just give you one thing. I'll give you the latent heat definition, and we'll practice questions on this, perhaps in an extra class. But these are the definitions. And whatever we did in this class today, you have to memorize it. The unit for thermal capacity, by the way, is joules. Write that. Because half a mark, 1 mark is for the unit in the exam. Even if you have the correct answer, you don't write the unit, you won't get any marks. Latent heat unit is joule. One thing is missing in specific heat capacity. It's not actually joule per gram, it's joule per gram per degree Celsius, or joule per gram per degree Celsius. Finished. Last thing is, yep, this.
Done, sir.
Finish writing the thing on latent heat.
Yes, sir.
That's it. So latent heat of fusion is with fusion, is with melting, and evaporation is with boiling.
Wait, can you go up a little?
If you haven't finished writing, take a screenshot. And see, well, I want this in your notebook. All right. Ayan, send me a picture of your notes after class. All right.
Okay, sir.
All right. That's all for now. We'll look at just a second. I'll give you the equation as well, which is E is equals to mn. Over here, E is equals to mc delta T. That's it. L could be F or E. Let's just say E equals M.
Wait. Okay.
All right. E equals ml. And the only thing remaining is transfer of heat now. Conduction, convection, and all of that. And practice questions on this. Now, learning all of the definitions is the first step, but questions is the main thing. Now, you won't believe the kind of questions we get in this chapter, especially thermal capacity. When you guys finish everything properly, we'll have tests on this. If you can score more than 60% or 70%, then you should know that you're pretty good. Fine. Now we're going to start the next class in 5 minutes.